Thank you, Mr. Chairman. To the President, Dr. Buchholz, I'd like to express my gratitude for being given this opportunity.
Okay.
Dietary salt intake is nowadays globally known as one of the major treats for cardiovascular health. Dietary salt intake may also influence idiopathic calcium reflux onset and recurrence. In the EAU guideline on oral sciences, daily sodium intake should not exceed 3 to 5 grams the prevention of recurrence. High daily sodium intake adversely affect urine composition. High daily sodium intake cause increased calcium excretion, reduced urinary citrate, and increased risk of sodium urate crystal formation. In the AUA guideline on medical management of kidney stones, the panel supports a target of less than 2,300 mg sodium intake daily. I'd like to talk about dietary issues. There is some confusion about the difference between salt and sodium intake. Dietary salt means the intake of sodium chloride. However, foods may contain small amounts of sodium bicarbonate and sodium citrate. Sodium is harmful for blood dialysis only when it is accompanied by the ion chloride. It is important to consider salt intake, not sodium intake. Salt is mainly supplied through processed food. About 10 to 15% of total salt intake is salt that is naturally contained in the food, and only a small percentage is discretionary added to foods. 24-hour urine collection is generally considered necessary because there may be some daily variation in sodium output. However, an estimation using a casual urine specimen can sometimes be acceptable for monitoring for research purpose. The World Health Organization recommendation states that daily salt intake should not exceed 5 grams. However, modern diet in many industrialized countries contains an excessive amount of salt. I'd like to take a moment to discuss epidemiology. There have been some large prospective studies that show positive and negative connection between salt and fluorosis. A large American prospective study conducted on healthy middle-aged women showed a clear increasing trend in the relative risk of developing stone as the quantile of salt intake grows. However, other large prospective studies failed to demonstrate such a correlation, especially in younger women and men. Dietary habits of idiopathic calcium stone former include a significantly higher daily intake of salt. Another study found that dietary habits of idiopathic calcium stone former included more frequent consumption of salty foods such as the sausage and ham than healthy control, especially among younger females. I'd like to talk about the effect of salt on urinary parameters of esogenic risk. In 1964, Hillman first reported an association between salt intake and calcium excretion, documenting a dramatic rise in calciuria after the shift from a very low sodium diet to a very high sodium diet. It has been reported that dietary increase of 6 grams per day in salt intake result in 40 milligrams per day increase in urinary calcium. The level of calcium excretion are different in stone and healthy subjects with the same sodium intake. It is generally high in stone than healthy subject. A 6 grams per day increase in salt intake may result in a 40 milligrams per day increase in urinary calcium in non-stone but an 80 milligrams per day increase in urinary calcium in stone. An excellent study was published by the Kidney Stone Clinic of Palmer University Hospital. Stone of both sex had higher level of calcium excretion for each category of salt intake. In the renal proximal tube, calcium handling is strongly dependent on the sodium. High dietary salt intake induced a high sodium load of kidneys and the status of relative hypervolemia. This condition diminishes the efficacy of sodium, water, and calcium reabsorption in the proximal tube. On the other hand, calcium reabsorption is unrelated to volume state in the distal tube. Approximately 55 filtered load of calcium is reabsorbed along the proximal convoluted tube, and an additional 10% is reabsorbed in the proximal striated tube. About 20% of filtered calcium is reabsorbed in the thick ascending loop of Henle. A high level of urinary calcium is one of the main risk factors for developing kidney stones. Other mechanisms of salt intake or lysogenesis are as follows. Increased urinary supersaturation index for calcium phosphate and uric acid. Decreased metasave limit for calcium oxalate. Impaired citrate excretion by acidosis induction. Increased oxalate excretion with hypertension. I'd like to talk about interventional study for reducing salt intake. Here is the report that dietary salt reduction results a reduction in calcium excretion into healthy subjects. The dietary approach to stop hypertension diet approach supports salt reduction to decrease calcium excretion. Taylor found a DASH-style diet was associated with lower rate of kidney stone onset and recurrence. The DASH-style diet does not distinguish the effect of other nutritional elements, such as protein, fruit, and vegetables. However, some recent studies demonstrated that reduction in salt intake was able to correct hypercalciuria. I'd like to talk about our experimental study regarding the molecular mechanism of salt for stone formation. The salt-sensitive rats were randomly divided into the 5 groups. These rats were fed a diet consisting of 0.3% or 4% sodium chloride. stone formation was induced by 0.5 ethylene glycol and 500 microgram per animal alpha-calcidol administration. Urinary supersaturation of calcium oxalate was elevated in the high salt diet group and stone formation group. The high salt ethylene glycol and alpha-calcidol group had the highest elevation of activity products. Urinary excretion of 8-hydroxy-2-deoxygenase significantly increased only in the high salt ethylene glycol and alpha-calcidol group. In this slide, we show the gene network in the kidneys. The obtained microarray data was analyzed using ingenuity pathway analysis, so-called IPA. IPA is a huge database of gene-to-gene network and created using studies of gene-to-gene interaction that have been published in paper. mRNA expression change in each treatment group were analyzed in IPA and automatically produced expression change gene network shown. Gene expression change was different among the group, but all of data show the main contribution of MAP kinase, AKT, and NF-kappa B as the central regulator of network. These networks can be activated in either regulation of stone formation or response of kidney cells. This slide shows the result of the validation of candidate mRNA expression by semi-quantitative RT-PCR. The band intensity of each PCR product in gel was quantified by the imaging software ImageJ. The average of relative intensity and standard deviation of for animal per group are shown. We classify gene into 3 categories consisting of upregulation, downregulation, and EPA-regulated gene. This slide shows the upregulated gene group. The gene of upregulated group were RUX155, CP, and MMP7. Graph D and E show the result of the downregulated group, and graph F shows the EPA-effective group. The gene of the downregulated group were claudin-10 and uromodulin. The gene of EPA-effective group was TGF-beta 2. Salt intake affects urinary supersaturation, oxidative stress, and alter gene expression concerning crystal formation, cellular dysfunction and injury, and crystal adhesion. In conclusion, salt intake is associated with the urinary excretion of calcium and citrate. Reducing salt intake may be an effective preventive measure for idiopathic nephrolithiasis onset or recurrence. Salt intake alters gene expression concerning stone formation. Thank you. Thank you for your attention.